Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video you will learn about Python's while loop, which is fundamental to machine learning and artificial intelligence and has some use in data science algorithms. The while loop is a simple inbuilt, or you could say native, Python function which iteratively on a step-by-step basis moves through a concrete or abstract program or a data storage collection. The while loop is a fundamental aspect in all types of computer use. The fundamental while loop at a microscale is the basis for persistent or memory-resident programs in computers. The while loop is the fundamental code that most often is used to make graphical user interfaces work with your mouse and your keyboard. The while loop makes artificial intelligences, machine intelligences, and robots continue to function and execute their programs. And in the case of data science, while loops are sometimes used in algorithms as an alternative to for loops due to the while loop's programming language properties and implicit pointer to an abstract or even at the time of computation changeable quantity, whereas for loops often require an unchangeable or concrete data storage collection for operation. Now we'll talk some more in detail about the while loop. So, the while loop, what is that? And we can say that the while loop is an inbuilt or native function which iteratively, on a step-by-step basis, moves through a program or a data storage collection. The while loop is often considered a special case of the for loop, although the opposite may be truer in terms of generalization. The while loop's code is kept iterating, or you could say repeating itself and its code until a specified logic condition or defined event becomes false, or using a slightly more advanced expression, true. The while loop's design consists of the user-defined code, which is to be executed for every iteration. It consists of the user-defined logical requirements, or you could say event, to stop iteration or repetition, and possibly the user-defined attached code that may break or stop the execution of the while loop, possibly with no connection to the executing code other than the existence of the code inside the while loop's code. And we should say that it is very possible to break the while loop using code which is completely external to a while loop. The while loop is fundamental to machine learning and artificial intelligence in terms of providing persistence to programs and applications, because it provides continuous operation or execution of a program until a condition is met or an event occurs, for example, that the user pushes a particular button, such as the on-off button, double-clicks a mouse button on a graphical object, or that a machine detects a particular circumstance. For example, it could be sunrise, it could be nightfall, it could be weather, it could be rain, the wind is blowing, motion, heat, heartbeats, or anything that the machine can measure and has programmed code to handle. It could be that a detector finds something, that a laser beam is broken, that it is unbroken, that it changes length, pixels that moves on a video screen, it could be sound, or it could be anything similar or measurable. It is for the data scientist or machine learner to define the logic condition or event for the while loop, and the while loop's only purpose is to execute the coded statements within the loop until the while loop's condition for continuing becomes false, or a piece of attached code within the while loop instructs it to break the loop and cease its operation. And we can say that while loops are sometimes used in algorithms as an alternative to for loops due to the while loop's programming language properties and implicit pointer to an abstract or even at the time of computation changeable quantity, whereas for loops often require an unchangeable or concrete data storage collection for operation. And what this means is that if we have a data collection with objects or items, the for loop can execute on this collection of users while it is changing. For example, unprocessed users or items inside the collection may be deleted, or you could have new added to this collection while the while loop executes. And many types of for loops fundamentally requires every item inside the collection it operates on to be enumerated. Whereas the while loop can accept linguistically a-changeable quantity or an abstract quantity, for example, inside a program or similar. So right, on the screen you can see an example of the while loop. This while loop uses an integer loop counter variable and a coded logic statement which states that while the loop counter variable is less than our specified integer value, the while loop will continue to repeat itself. Every time the while loop repeats itself, the loop counter will increase with 1 as described by the code, and the print function will print the value of the loop counter. So, the while loop will continue to repeat itself until the loop counter variable becomes larger than the particular value which we have specified as the condition for falseness of the continuing execution of the while loop. And we can say that one double-sided issue and useful property of the while loop are that a while loop may continue to execute endlessly unless we have some attached terminal property, rule, or shutdown function included in the while loop. And this is a serious issue because while loops may freeze the execution of a program if it is not sufficiently controlled. And this property is also an absolute necessity and useful property for automated machinery, machine learning, robotics, and artificial intelligence, because this property provides the ability to continuously run a program, for example, without any human input. So right, now we'll type some Python while loop code. So start up your code editors, because now we'll type some code. All right, having started our code editors, we will type some while loop code. And we will start to type while loop. And we will type our first while loop. So we type loop counter equals 0. And we type that this is an integer variable we will use to keep track on the number of repetitions or iterations of our while loop. So we type while loop counter is less than 10. Loop counter equals loop counter plus 1. And we will print the loop counter variable for every iteration. And we will print this is the final value of the loop counter integer variable. plus string loop counter. And we close the print instruction. And what this code does is that it initializes the loop counter integer variable to 0, and it creates a loop which will, every time it iterates, increase this loop counter variable with 1. And this will keep repeating as long as the loop counter integer variable is less than 10. And we have determined this value arbitrarily. So it could be 100, 1000, a million, or whatever number you choose. This is just to demonstrate how the while loop functions. So let's run this code. And as you can see, the program typed for 1 to 10. And the loop terminated because 10 is larger than anything that is less than 10. So we can say that 10 is larger than our requirement 9 for continuing to repeat the while loop. And please note that in this loop, we printed the loop counter variable after it has been increased by 1. And the result is that the loop counter equals 9 starts the loop as less than 10, but is printed as 9 plus 1, which equals 10. So now we'll talk about while loops, infinity while loops, and break statements. And we can say that while a while loop is a great tool for keeping a program running indefinitely or persistently, forever loops may also lock a program in execution mode. And one of many ways to handle this is to insert break statements. And we can say that while a while loop is a great tool for keeping a program running indefinitely or persistently, forever loops may also lock a program in execution mode, and in some instances force us to shut down our computer, although the current modern operating systems often have another while loop, which we can call upon to terminate our forever executing while loop. And another way to stop a while loop from executing is to insert break statements. So we type this while loop creates a possible infinity loop without break exits from the loop. Or we could say this is a very funny linguistical thing. We can change this to if there are no break exits from the loop. So here we will create an example of a while loop which will execute indefinitely unless we use the break statement, which we will implement inside this while loop. So we type loop counter 2 equals 10. And we type while loop counter 2 is larger than 5, loop counter 2 equals loop counter 2 plus 1. We will print loop counter 2, and we will state if loop counter 2 equals 20, break. And we will print this is the final value of the loop counter 2 integer variable. Plus. And we close the print instruction. So here we have a while loop which will continue to execute indefinitely without this break statement. So initialize the loop counter 2 variable at 10. It will increase with 1 for every iteration. And we state that as long as it is larger than 5, which it already is at the beginning of this loop, it will continue to iterate this loop. And here we have a break statement which catches this execution and breaks the while loop, because with these variables and this statement, this break statement condition must become true. So let's run this code. And here we can see that we started at 10 plus 1, 11, reaches 20, and the while loop is broken, or you could say terminated. And as you can see from this artificial example, it is very easy to create while loops that keep iterating or repeating forever or for a very long time, especially if complex conditions for the falseness of the loop condition is used. It is considered Pythonic behavior to not create hard to understand or analyze logical statements such as while logic statement 1 is true and logic statement 2 is true, and logic statement n is true or false. This while loop will continue, because the programmers that will read this code will have a very hard time to understand the logic conditions. And according to Python's doctrine, programmers should not have to calculate, they should not have to handle extremely complex logical statements. So they shouldn't have to sit with a pen and paper and try to figure out the logics of the while loop. It should be simple and preferably only be one statement. So let's take a look at an, you could say, algorithmic way to use while loops with Python lists. And here we could make a note which says that this is intermediate to advanced level. So if you find this code hard to understand, it is just to continue to the next video. And when you have completed this section, you just return and watch this video again. You type some code, and this will be very easy for you to understand. So right, now we're going to type some while loop with Python lists. And we'll begin to create a list. We create an empty list, which we call list tested. And we create a list, which we call untested. And we populate this list with strings denoting animals. We can have a cat, we can have a dog, we can have a horse, we can have a bull, and we can have a cow. And we can make our while loop. We can say while the length of the list untested is larger than 0, we will print testing a animal. And in this case, we will point at the first animal in the list. And we will test this animal. And after testing it, we will append it to the list of tested animals. And we will pick it from the list of untested animals and move it to the list of tested animals. And we will print all these animals have been tested or has been tested. And we will print the list of tested animals, and we will have a separator like this. So here we have a list of untested animals. We have an empty list which will describe our tested animals. And the condition for continuing this while loop is that it is larger than 0, that it has animals remaining in the list. And for every iteration of this list, we test the animal by printing it, and we move that animal from the list of untested animals to the list of tested animals. So let's run this code. And here we can see that the first animal was a cat, and it was tested. The second animal was a dog, and it was tested. And here we can see the new list of tested animals. And here you can see one of these ways to abstractly address a collection, because here we only talk about the length of this list. And as we test it on every repetition of the loop, theoretically, this list could change and have, for example, more animals added to it while executing this loop. So, for example, if you run this while loop to the horse, and this list got some other animals, for example, a parakeet and a lion added to it, this while loop wouldn't break down. It would just get a new number here. Whereas for some other looping schemes, they would only consider the numbers here. So they would count this as 0, 1, 2, 3, and 4. And they would say, iterate for this collection and nothing more. And if you added more animals, these other loops would either break down or they would refuse to execute for these new additions. So here we can see one of the strengths of the while loop. And we can type that a similar design can be implemented with Python sets. We will create a set original, and we will simply borrow the animals. We will create a set tested, which will be equal to an empty set. We will have a set untested, which we will initialize as the set original difference with the tested set. And this equation will simply make the set untested to be equal to the original set, because this set is empty. So the difference between this set and this set is this set. So right, let's print the original set plus string set original. And we will create our while loop. So we type while the length of set untested is larger than 0. Set tested memory equals set tested dot copy. And we can type that this creates a set memory between the loop iterations. And this is a very old school way to handle this memory between iterations of a set. We type set tested add set untested pop. And we will state that this line moves a random animal from the untested set to the tested set. And we will print tested animal this iteration plus string set tested difference set tested memory. And we can print untested animals plus string set untested, and we can print tested animals plus string set original difference set untested. So let's run this code. And here we can see that the original set was cat, horse, bull, cow, and dog. And if you recall from the set video, a set is unordered. So here you can see that we have a new order as compared to the order of the list. And this instruction draws items from the set randomly. So the first animal we test is the cat. And after testing it, we can see that horse, bull, and cow are untested, that the tested animal is the cat. And for the second iteration, we can see that the selected at random animal to be tested is a horse. And after testing it and moving it to the tested set, we can see that the bull, cow, and dog are untested, and that the cat and horse are tested. And for the third iteration, we can see that the bull is tested, and that the cow and dog remains, and that the cat, bull, and horse have been tested, and so on. And as you can see, this can be very useful for algorithmic purposes. So, all right, now we'll display that the multiple conditions for while loops are considered non-Pythonic. And we will also say that you should try to limit them to preferably at most 2 conditions. And of course, most preferably only 1 condition. So we type multiple conditions are generally non-Pythonic. And we will reinitialize our set. we must rerun this code, and we must take our set memory and put it equal to a set. Like this. And we will state that while the length of the set untested is larger than 0 and not string set tested difference set tested memory equals a dog. As you can see, this is hard to keep track of. And we can say that this condition, which is double and a negated logic statement also on a cast advanced collection, which is also computed one time and also set to be equal to a string, is an extremely complex condition. And we can say that this will stop the loop either when or after a dog is tested, or when the dog is lost and the untested set becomes empty. We will type set tested memory equals set tested copy. And this creates a set memory between the loop iterations. So we will type set tested dot add set untested .pop. And this will move a random animal from the untested set to the tested set. And we will print tested animal this iteration plus string set tested difference set tested memory. And we will borrow this code. And we will type Pythonic is simple rather than complex. So let's run this code. And here we seem to have been lucky because dog was selected on the last iteration. So let's change the dog condition to a cow. And let's run this code again. And as you can see, in this case, the algorithm stopped after testing the cow. So what remains is a set with an untested dog. And if we change the condition again and run this code, we can change it to a cat, which is the first animal in this particular random draw. So let's run this code again. And here you can see that the first animal to be selected and tested was the cat. And because of this logical condition, this while loop will not continue to execute after testing the cat. So the only animal that was tested was the cat because of this logical condition. So right, this demonstrates why you shouldn't use very complex conditions for while loops, because the code very quickly becomes unreadable and hard to understand. And now you know why Pythonic is simple rather than complex. So right, now we have shown you the while loop and some useful and practical ways to use it. In the next video, you will learn to use the extremely useful for loop. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video we will talk about Python's for loop, which is fundamental to data science, data analysis, machine learning, and most other parts of programming, computing, or computer use. The for loop is used in almost every calculation, from the simple mean or simple sum to advanced super-parameterized math or machine learning models. The for loop is likely the most commonly used pattern of all patterns within data science and machine learning. As a type of pattern, the for loop executes statements for each item in a defined range or for each object in a collection. The for loop is generally used to either execute a particular calculus for each object in the collection, or for calculating a number from each object in the collection, or for generating a number of objects in a collection from a given range, the number of positions in the collection, or other numbers. Let's talk some in detail about the for loop. Now we'll talk about the for loop in more detail. And the for loop executes statements for each item in a defined range or object collection, such as a Python data storage dictionary or a list. The precondition for using a for loop is that the object it is used on has the iterable property. And this means that the for loop may walk through or iterate over each item in the given range or each object in the collection. And the for loop executes its statements or its block of code for each element, item, or object in the range or collection. The for loop is the most used pattern within data science, data analysis, and machine learning. The for loop is necessary for fundamental functions such as the calculation of a mean or an average for a collection of objects. And this is because the calculation of the total and the divisor requires that each object in the collection it is used on must be touched or read at least twice or 2 times at once by the algorithm to calculate the total sum of the values of the objects and to calculate the total number of objects. Let's take a look at the screen. And here we have an example of a very proper for loop code that reads the content of a Python list and prints the content to screen. A second way to use the for loop is to calculate, for example, a parameter from each object in a collection or Python list, here exemplified by the calculation of a simple sum with the currently read-only for loop. A third way to use the for loop is to use it to populate a collection with generated objects. Here on the screen you can see a list where the for loop creates the index externally using the range function and inserts a random integer value in the list at each of the generated indexes from the range function. A fourth algorithmic way to use the for loop is with the length and the range functions. This way is capable of writing to the respective positions given by the range function, and this expression has been developed from the mathematical language and is therefore often used with algorithmic recipes as a way to make the math readable, whereas this expression quickly may become non-Pythonic complex, and therefore currently somewhat penalized performance-wise in Python's compilers. A fifth, more Pythonic way to use the for loop is with the enumerate function, which creates an index in a less flexible way than the range function, but is way more Pythonic, often with the same compiler footprint as standard range and length functions. A sixth very interesting way to write for loops is Python's list comprehensions. These expressions are compact and considered highly Pythonic for one-liner expressions, less Pythonic for more complex expressions. These list comprehensions have received some extra care in the Python's compiler, and therefore in some cases are executed with different speed than other Python for loops. So all right, now we'll type some Python for loop code and discuss some deeper knowledge about for loops and associated tech. So start up your code editors, because we will type some for loop code. All right, having started our code editors, we will type some for loop code centered on using Python lists with integers to show and explain some of the magic with Python's very expressive battery of for loops and some specialized functions. So let's type what this code will be about. We type Python for loops. And we will begin with creating a Python list with integers, which we will use for showing our for loops. So we type create a Python list for use with our for loops. And we call it list 1. Equals 1, 1, 2, 2, 3, 3, 4, 4, 5, and 5. And we will print our list 1. So let's run this code. And here we can see that we have a list of integers. And now we will use Python's simple object-oriented for loop to read the integer objects inside this list. We type for item in list 1, print item. And we run this code. And here we can see that we have printed each item in the list. And we will say that this is the currently fastest native way to loop a list in Python and read the list contents. And we will say that currently Python doesn't allow you to use this fast method to manipulate the content of the list without additional complex additions. And maybe this will be implemented in Python 4 because this way of typing for loops is very appealing and it is very nice and very easy to read and understand. And we must say that despite the alleged speed of this for loop, it is possible to increase the speed of this expression using faster languages to increase the speed 10 times to 100 times, or with machine assembly languages even more, possibly to speed up this type of code 100 to 10,000 times. Yet this ordinary Python code is fast enough on a 5-year-old computer, in 2025 for millions and billions of data points. And this is something to consider when coders discuss the speed of an expression in the execution phase as compared to actually designing the code and plan all its use. So, all right, we create a new cell. And now we'll take a look at a more common and more algorithmic way of using the Python's for loop. So we will create a for loop to iterate over the list and change each item or element using the index of the range and length functions. To address the list's index. We type for item in range of the length of list 1. List 1 item equals list 1 item plus 1. And we will print list 1. And we can type that this way of writing the for loop is currently because of Python's compiler equivalent to a more advanced Python for loop with the Enumerate function. So let's run this code. And here we can see that we added 1 to each item in the list. And we can say that this code is slightly slower than this code. And we can say that this is an active choice of Python's designers to try to force more Pythonic future code, whereas the algorithmic way of writing the for loop likely can be optimized to a faster code execution due to all older static languages using this type of looping for compatibility with the mathematical and numerical languages. And the advantage of using this way of typing the for loop is algorithmic compatibility and mathematical readability, plus detailed control of the code execution. The disadvantage is more complex code that easily becomes hard to read for programmers, but is easier to read for mathematicians and other algorithmic implementers. And we must also say that within data handling, which is what this video course is about, both of these ways of typing the code are equally right to use, even in cases where the loop is used for read-only purposes. And this is the fine line where persons doing data handling and/or algorithms often may clash with object-oriented Python programmers who prefers to use the Python for loop standard and the enumerate or list comprehensions to control the for loop logic. So, let's take a look at using the for loops with Python's enumerate function and list comprehensions. So we will type for loops can be used with Python's enumerate function to enumerate objects in a list. So we type for num item in enumerate list 1 list 1 num equals item plus 1. And here we can type that num is the index and item is the value. And we can print list 1. So let's run this code. And here we can see that we once again added 1 to each item. And about the enumerate function, we can say that in most textbook cases, the enumerate for loop will generate the same machine code as the range and length function. And this is related to the list and its implementation, where the first object always is labeled 0, the second 1, the third 2, and so on. But here we have an important difference, because the enumerate function is, however, able, or it is possibly able to generate a different index from the list than the range and length function can generate from the range function. And this is two different sources that almost always yields the same result. And here we can say that Python programmers, they like this enumerate function, and the mathematicians and algorithmic persons, they like the range and the length function. So let's take a look at list comprehensions. And we will start to type that list comprehensions can do a similar job with a 1+ liner. We can type list2 equals item plus 1 for item in list 1. And we can print list2, and we can print list2. So let's run this code. And here we can see that we once again added +1 to each item in list 1. And we printed list 2, which we generated, and we printed the elements of list 2. And about list comprehensions, we can say that list comprehensions utilize other optimizations than ordinary for loops. And once again, this is a developer selection of optimizations for the compiler. And list comprehensions are considered extremely Pythonic for one-liners using a one-dimensional list, but may grow non-Pythonic with multidimensional lists and advanced expressions. Because these algorithms can be very complex and they can have many lines of mathematical expressions that must be translated to code. And these list comprehensions may not be easy to read and becomes non-Pythonic with multiple dimensions and complex expressions. So all right, let's talk some about simple and common uses of the for loop. We type the for loop can be used with other operators than plus, add, for example, multiplication. So we can type for item in range of the length of list 1 item equals list 1 item multiplied by 1000. And we can print the elements of list 1. So let's run this code. And here we can see that each element in list 1 has been multiplied with 1000. And in this case, we made this range and length for loop a one-liner. And there are many ways to use these for loops. So we can say that for loops can be used for many types of tasks. For example, to iterate over lists of strings. We create a list animals and we give it a dog, a cat, a horse, a bull, and a cow. And for animals, in list of animals, print animal. And let's run this code. And here we can see that the for loops can be used with lists of strings. And as you can see, this is very easy to print. It is very little code and it is very effective. And we can also extend this example to the enumerate function. We type for loops can be used with Python's enumerate function to enumerate objects in a list, which can be very useful in some use cases. So let's type for num animal in enumerate list animals, print, num and animal. And we can say that this can be a very useful trick when creating a dictionary from a list, considering the need for unique keys to create a dictionary. And we can say that this is also useful for many other data operations where enumerations currently are a necessary alternative to Python's read-only for loop. So let's run this code. And here we can see that we have created a index for each animal in the order they are placed in the list. And this means that we can convert this list into a dictionary and use the list position as the key to the dictionary. And as I said, this can be very useful in some situations. And now we'll take a look at the range function. And we can say that for loops can be used on ranges or part of lists or collections. And we will use list slicing with for loops. We type for animal in list of animals, and we can take 0 and 2, print animal. So let's run this code. And here you can see that we sliced away the last 3 animals and only printed the 2 first animals. And this range function and length function can be used with some flexibility. We can type that we can use ranges and the length function. And for example, steps of 2. We type for animal in range of 1, the length of the list of animals, and step. And we can print list of animals and the respective animal. So let's run this code. And here we can see that we started on position 1 and we took them in step of 2. So we started with the dog and step 2 is the bull. And then the list ends. So here we can see that these ranges and length functions have some flexibility when they generate list positions for the for loop. So, all right, do you remember that for loops could be used to create content for lists? So let's import some. So from random, we import randrange. And we can say that this function gives us random integers when we call this function. And this time we enter the import here in the code, in this cell. And to be Pythonic, we should place this import at the start of this program. But in this video, we place it here, in this cell, where we will use it. We create a new list, which we call list2. We make it an empty list, and we type for item in range of, we start at 0, we end at 4, steps is 1. We will insert at the position item a randrange item from 0 to 4. And we will print list2. So let's run this code. And here we can see that we generated 4 random numbers and placed them in a list. So here we have used the for loop with the range and a random number generator to create and populate this list with a few random numbers. So, all right, do you remember that for loops often are used to calculate parameters? So let's type. Remember that for loops often are used to calculate parameters. We can type parameter sum equals 0. And for item in list2, we can type param sum equals param sum plus item. And we can print the parameter sum. So let's run this code. And here we can see that the sum of all of these integer objects is 5. So here we use the read-only Python for loop to calculate a parameter. And as you can see, this is very simple code, and this is easy to read, and this is easy to understand. So what we will do now is that we will go to the advanced part of this video lecture. You can type advanced section, for loops, and multidimensional lists. And as usual, if this content feels too advanced, just continue this section and return afterwards. And with repetition, you will discover that this code has become very simple and easy for you to understand and handle. And now we will begin. To create a 2D list with some random integers. We will type list4 equals an empty list, list5 equals an empty list, list6 equals an empty list, and list7 equals list4, list5, and list6. And this code will create an empty two-dimensional list of lists. And we will use a for loop and the rand range function to populate lists with random integers. We type for list in range of the length of list 7 for item in range of 0, 4, and 1, list 7, list, insert item, rand range 9. And we will print list 7. So let's run this code. And we can say that the result is a two-dimensional list of lists with integer content. And this is a very common data shape with some resemblance of a simple Excel spreadsheet. And we can use a for loop to calculate parameters for rows and columns. For example, simple sums in 2 dimensions. We type param list1 equals an empty list and parameter list2 equals an empty list. And now we will use a more detailed expression for this calculation. We type this is one of the more detailed expressions for this calculation. It is slow, but gives maximum control of the calculation. And the ability to touch each and every integer object or list position in the list of lists. We type for list in range of the length of list 7, param sum 1 equals 0, and for I in range of the length of list 7, list param sum 1 equals param sum 1 plus list 7 list I. And we add the calculated parameter to param list 1. We will append param sum 1. And this is one of the dimensions of this list of lists. And now we'll take the other dimension. We type for I in range of the length of list 7. And here we will use a specified list 7 to calculate the length of the lists. And we type param sum 2 equals 0. And we type for list in range of the length of list 7. Param sum 2 equals param sum 2 plus list 7 list I. And we type param list 2 append param sum 2. And we print list 7 and we print param list 1 and we print param list 2. So let's run this code. And here we can see that the first dimension is 0 plus 5 plus 1, that's 6. The second is 5 plus 5 is 10 plus 2 is 12. And the other dimension is 0 plus 5 plus 5 plus 8, and that's 18, and so on. So here we can see that we have generated a spreadsheet-like design, or a design which is equivalent to a mathematical matrix. And we have learned how to calculate parameters in 2 dimensions using the for loop. And now we must say that you must please note that there are several Python functions. We could say specialized Python functions able to handle this particular case. We can, for example, type print list 7, and we can print sum I position for I position in list 7. And we can print sum of the list for list in zip list 7. So let's run this code. And as you can see, these 2 one-liners made a similar effect as the earlier, more complex code. So let's say that you should please note, while this code is very Pythonic and very expressive, it also puts you under the control of the owners of these functions and their even arbitrary whims in terms of developing the functions. Another issue with these, you could say, short and seemingly very effective code is that only Python coders understand these expressions, and that all of these functions may throw errors under certain conditions related to the length and content of the lists, or for example, not a list included in the list of lists. And we can say that using the more complex expression or the more basic Pythonic for loop expressions is a far bit safer, as they are atomic or near atomic, and changing them would create a need to rewrite millions and billions of lines of code unprotected from code changes, and possibly create an outrage and total mayhem around the globe. And this is why many experienced programmers prefer the more complex non-Pythonic expressions, because they feel that they own the control of the expression, the calculation, and the data. Whereas these short and effective and very Pythonic one-liner for loop codes may be very effective, but also gives away that control and the readability and the ability to take the expression and explain it to a non-programmer, or, for example, the persons who are doing the algorithms and all such things. So, all right, let's now modify the content of the 2D list of lists. We can type for list in range of the length of list 7 for I in range of the length of list 7 list. List 7 list I equals list 7 list I plus 1. And we can print list 7. So let's run this code. And here we can see that to list 7, 1 was added to every item. And we can try some other ways of doing this. So we can type or try for list in list 7 for num item in enumerate list num equals item plus 1. And we can print list 7. So let's run this code. And here we can see that we once again has added 1 to each element in list 7. And we can say that this enumerate function generates far less code work to type than the range and length function. And this can be useful in some situations, but lowers the control a little bit. Or try for list in list 7 for I in range of the length of the list I equals list I plus 1. And we can print list 7. So let's run this code. And here you can see that we once again has added 1 to every integer object in the two-dimensional list of lists. And here you can see that we combined Python's most Pythonic for loop, both with the enumerate function and with the range and length function. And here we can see that we can make these expressions almost equivalent. So, all right. Now we have a suggested advanced exercise. And this is to rewrite the for loops to handle lists of unequal length with integer content. And this is an advanced exercise. And you can do it as you please. And when you have completed it, you can be proud, because then you know that you could, for example, create the inner workings behind a Excel spreadsheet or in a database or any other spreadsheet like data source. So, all right, now you have learned to use the extremely common and useful for loop, plus you have gained advanced knowledge in the use of the for loop on multidimensional collections such as Python's list of lists. And you have also learned how to use the for loop to generate data for a range of numbers. You have learned some deep knowledge about Python's for loops, their use, the under the hood machinations and tech decisions, and you have been shown some specialized functions which are useful with for loops or as alternatives to for loops. And in the next video, you will learn even more. And we look forward to see you in the next video.